Let's look at a hypothesis test for a mean, part 2. This is a second example. When 40 people used the Weight Watchers diet for 1 year, their mean weight loss was 3.0 pounds and the standard deviation was 4.9 pounds. Test the claim that the mean weight loss for people using the Weight Watchers diet for 1 year is greater than 0 pounds. Based on these results, does the diet appear to be effective? Test the claim with 99% confidence because we want to be really sure. Okay, let's find null and alternative hypotheses. Note that this is a hypothesis test for a mean, not for a proportion. We saw that in the previous chapter. The null hypothesis, as always, means no change, no difference. The null hypothesis has an equal sign, so it's of the form mu equals mu sub 0, like mu equals 12. The alternative hypothesis means there is a change, there is a difference. And it's of the form mu does not equal mu 0, or mu is greater than mu 0, or mu is less than mu 0. Okay, our null hypothesis is that the mean weight loss for people using the Weight Watchers diet for 1 year is 0 pounds. In other words, no change, no difference. Weight Watchers has no impact. The alternative hypothesis, well, we'll represent the null hypothesis symbolically by saying y equals the weight loss for people using the Weight Watchers diet for 1 year, and mu equals 0. Now, an alternative hypothesis could be mu does not equal 0. We would choose this as the alternative hypothesis if we wanted to test the hypothesis that the mean weight loss for people using Weight Watchers diet for 1 year is 0 pounds. Or if we wanted to test the hypothesis that the mean weight loss for people using Weight Watchers diet for 1 year is not 0 pounds. In either case, we would use this as the null hypothesis, but this is not what we have. Mu is less than 0. We would choose this as the alternative hypothesis if we wanted to test the hypothesis that the mean weight loss for people using Weight Watchers diet for 1 year is less than 0 pounds, but that's not what we have. We would choose this as the alternative hypothesis if we wanted to test the hypothesis that the mean weight loss for people using Weight Watchers diet for 1 year is greater than 0 pounds. Ding, ding, ding. That's what we have. We choose this as the alternative hypothesis because we want to test the hypothesis that the mean weight loss for people using Weight Watchers diet for 1 year is greater than 0 pounds. Okay, let y equal the weight loss for people using Weight Watchers diet for 1 year. There's our null. There's our alternative hypotheses. We want to do a hypothesis test for a mean. Do the data satisfy the required conditions? Oh, you bet. It's a random sample, presumably. Sample's less than 10% of the population because the population's pretty big. As long as n is greater than or equal to 40, it's not extremely skewed. If there are outliers, we eliminate those. You bet. Okay, although you don't have to, but you might want to try that. You don't have to eliminate the outliers, but you might want to try. Okay. Null and alternative hypotheses. When 40 people used the Weight Watchers diet for 1 year, their mean weight loss was 3.0 pounds and standard deviation was 4.9 pounds. Calculate the test statistic t equals y bar minus mu sub 0 over s, or square root n. Okay, here mu sub 0 is the conjectured value of mu in the null hypothesis. In that case, that's 0. So that would be our mu sub 0. Okay, so t is y bar, we saw that was 3.0, minus mu sub 0, that's 0. S, the standard deviation, sample standard deviation was 4.9, and n was 40. When we calculate this, we get 3.872. Whoa, what does that mean? Okay, let's look at the t-distribution table. Again, it's in Appendix D of the textbook. You can go online and find that, or you can enter t-distribution table into a search engine. And here's what we get. We get something that looks like this. Blow it up. Okay, so as for the column, we're dealing with a one-tail test this time because we want the probability that mu is greater than such and such. That's our alternative hypothesis. Okay, it's a one-tail probability, and we have 0.01 because, again, we want to be really sure. We want to do this with 99% confidence, so our one-tail probability is 0.01. So this is the column we're dealing with here now. So again, 99% confidence, 0.01 is the probability. Sometimes we call 0.01 our significance level, or alpha. In other words, if we want 99% confidence, that means we want the probability to be 1%, that probability in the tail. And that would be our significance level. We represent that with the Greek letter alpha. The rho we're concerned about, well, again, the degrees of freedom is is 39 minus 1. I'm sorry, 40 minus 1, which is 39. Now, you'd think, well, 39 is pretty close to 40, so wouldn't we want to use the 40 row? No, we play it safe. We just round down. So we're going to use the 35 row and not the 40 row. Okay. So t equals 2.438, because that's what we get when we use the 35 row and this column. So 2.438. Okay, for alternative hypothesis is mu does not equal mu 0, the rejection region looks like this. The alternative hypothesis mu is less than mu 0, our rejection region looks like this. Here's what we have. The alternative hypothesis is mu is greater than mu 0, so our rejection region is going to be of the form t is greater than t star. And we just found t star a moment ago. Okay, our alternative hypothesis is one-sided. Of that form, we reject the null hypothesis if t is greater than t star. We just saw that t star is that. So we reject the null hypothesis if t is greater than 2.438. And this is what the t distribution looks like for 39 degrees of freedom. So if t is greater than 2.438, roughly here, if it's something in that region, then we would reject. Okay, but t equals 3.872, which is greater than 2.438. We conclude that the null hypothesis is false. We reject the null hypothesis. There is sufficient evidence to conclude that the mean weight loss for people using Weight Watchers diet for 1 year is greater than 0 pounds. Okay, let's find the p-value. What is the p-value? It's the probability value. It's the probability we would get a result this extreme, or even more extreme if the null hypothesis were true. So if the null hypothesis, let's see, our null hypothesis is of this form, mu is greater than mu sub 0, so we want to find the area to the right of t. That will be our p-value. Okay, if the null hypothesis were true, the probability that t would be 3.872, or even more extreme, gosh, you can't even fit it on here, can't even see it. That probability you can find on the TI. Go to Dister, choose T, CDF. That's A, B, DF. A is the left endpoint, which is 3.872. That should be a point and not a comma. Sorry about that. Then 10 is the right endpoint, and then 39 is the degrees of freedom. And when we enter that, again, this should be a decimal point, we get 2.0036 times 10 to the negative 4. So the p-value is 2.0036 times 10 to the negative 4. Because again, our p-value is the area to the right of t. So we don't multiply it by 2 as we did in the two-sided test. Okay, so that's our p-value. If the p-value is less than 0.05, we reject the null hypothesis. Oh, if the p is low, the null must go. So we reject that null hypothesis because, look, our p-value is 0.0002, and that's a lot smaller than 0.05. Okay, why is the weight loss for people using Weight Watchers diet for 1 year? Those are our null and alternative hypotheses. We reject that null hypothesis because the p-value is so small. There is strong evidence that the mean weight loss for people using the Weight Watchers diet for 1 year is greater than 0 pounds. Now, if the p-value were close to 0.05, like 0.04 or 0.06, we'd say there's some evidence. And if the p-value were big, like 0.25, then we'd say there's insufficient evidence. Does the diet appear to have practical significance? Well, there's a difference between statistical significance and practical significance. Statistical significance means we reject the null hypothesis. Or in other words, it appears that H sub A, the alternative hypothesis, is true. That's what we have in this case. We have a statistically significant result. But practical significance, or clinical significance we sometimes call it, it means it has an effect, an impact on your daily life. Well, this method of weight loss has statistical significance, but not practical significance. Because 3 pounds, yes, it was statistically significant. We did reject the null hypothesis, but the practical significance is negligible. By the way, a more recent study out of Duke University indicated that the average person using Weight Watchers for 1 year lost about 5 pounds. So it works for some people, like Oprah, for example. It doesn't work for everybody.